Guys, welcome to Physics Clinic. So today we'll continue with our topic of SS2 motion, and today we are going to be discussing about terminologies, wave equation, motion under gravity. So let's go to terminologies. So for terminologies, when we talk about terminologies, what we are talking about is the terms that we are going to use for this topic. So under that, let's talk about the first one. So the first term is what? Displacement. So when we talk about displacement, what is displacement? Displacement is the distance traveled in what? A specified direction. So it is a vector quantity because it has what? A specified direction. Its unit is in what? Meters. So we talk about distance. Distance is the space or separation between what? Any 2 points. It is a scalar quantity, meaning that it has only magnitude but no direction. It's also measured in what? Meters. So speed is what? The rate of change of distance with what? Time. It is a scalar quantity. It is measured in what? Meter per second. And the formula for speed is what? Distance over time. So let's talk about velocity. Velocity is the rate of change of displacement with time. It is a vector quantity because displacement is actually what? A vector quantity. And it is also measured in what? Meter per what? Second. So velocity is what? Displacement over time. Okay, let's go to the next one. So the next one is what? Acceleration. Acceleration is what? The rate of change of what? Velocity with time. It's also what? A vector quantity because of what? It has a relationship with what? Velocity. It's measured in what? Meter per second square. Now we have what we call retardation or deceleration. So retardation or deceleration is actually what we call negative acceleration. So mathematically, acceleration is what? Velocity over time. Now let's talk about the equations of motion. We have dealt with all this in our SS1. So we are just trying to do a recap on it. So basically we have 4 equations of motion. So we have the V equals to U plus AT. We have the S equals to UT plus half AT squared. We have V squared equals to U squared plus 2AS. And we have S equals to V plus U over 2 times what? T. So these are the four equations of motion. Work example. Now look at this first example. Example 1. A car moves from west with an acceleration of 0.5 meters squared. Find its velocity when it has covered a distance of what? 100 meters. Now the first thing you have to do is that for this kind of question, you have to first of all get what are those things that are actually given to us. Now for the question, you see that the car moves from west, meaning that it's starting from west. So for something to start from west, it means it was not moving initially, and meaning that what its initial velocity is what? 0 meter per second, and its acceleration is 0.5 meter per second squared, and distance it covered was 100 meters. They asked us to find the velocity when it has covered 100 meters distance. So what you are going to do is that, what are we looking for? We're looking for velocity. Now you check the 4 equations of motion. Which of them can we use to solve this problem? And that is actually the third equation, which is V squared equals to U squared plus 2AS. So imputing these values into this equation, so U squared becomes 0 squared plus 2 times 0.5 times 100. So V squared will give us 100. So what we have to do is that we have to square root both sides. So squaring both sides, V is going to be square root of 100, which is going to give us V is what? 100, that is 10 meters per second. So the velocity of the car when it has covered a distance of 100 meters is 10 meters per second. Let's go to the next question. A car travels with a uniform velocity of 30 meters per second. How far does it travel in half a minute? So what you are going to do is convert that half a minute to what? Seconds. Remember, always change to the SI unit. So V, velocity is what, 30 meters per second. Y, the time is half a minute. And remember, 60 seconds make 1 minute. So it's going to be half times 60, which will give us 30 seconds. So we are looking for a distance. So remember that speed is what? Distance over time. And then making distance inside the formula, distance will be speed times time. So imputing our values, distance is going to give us 30 times 30, which will give us 900 meters. Remember, this is physics, not math. Always impute your unit. Now let's go to the third example. Example 3. So example 3, we have a question like this. This is more like a theoretical question. So how do we solve this question? So the question says a car starts from rest and accelerates uniformly until it reaches a velocity of 30 meters per second after 5 seconds. It travels with this uniform velocity for 15 seconds and it is then brought to rest in 10 seconds with a uniform deceleration. Determine the acceleration of the car, the retardation, the distance covered after 5 seconds, and the total distance covered. So the best thing to do for this kind of problem is to draw a velocity time graph. So drawing a velocity time graph, look at it. They say the car starts from rest, so meaning that the velocity time graph will start from this point, that's the origin, and it accelerates uniformly until we have a velocity of what, 30 meters per second, and that occurred after 5 seconds. This is the time axis. Now it continues at this 30 meters per second for the next 15 seconds. So at this place it will now be 5 plus 15 to give us 20, and then it was now what, brought to rest. Brought to rest means it got back to zero through uniform deceleration, and that occurred after another 10 seconds. So that is 20 plus 10, which is 30. So they asked us to find the acceleration. Acceleration is actually the slope of what? Velocity time graph. Okay, let's go back. So acceleration is the slope of a velocity time graph. So looking for the acceleration, so what we are going to do is acceleration, remember slope is the y ds. So the y in this case is the velocity axis and the x in this case is the time axis. So that's going to give us AE over OE. So this is going to give us 30, that's this place, the height of this place is 30 over what, 5, which is given us 6 meters. So which is give us, so 6 meters squared. So retardation is this place. So the slope of this place, so that is CB over what, DC. So this is going to give us 0 minus 30 over what, 10, which will give us what, minus 3 meters per second squared. So let's talk about the what, distance it covers after 5 seconds. For us to find the distance it has covered after 5 seconds, it will be the area under the acceleration side. Now, and that is going to give us the area of what, the triangle. And area of a triangle is half times base times height. So the base is the time axis, while the height is the velocity. So that is going to be half times 5 times 30, which is going to give us what, 75 meters. So they asked us to find the total distance covered. So total distance covered is the area under the whole graph, and the area, the shape under the graph is a trapezium. So we are going to look for the area of the trapezium. So what we just got to do is area of the trapezium is half, that is A plus B times H. So that is our A is going to be AB, while our B is going to be OC times what, H. So imputing our values, so we have this to be half times 15 plus 30 times 30, and that is going to give us 45 times 15. So the total distance covered for the entire journey is 675 meters. Okay. So let's talk about motion under gravity. So motion under gravity means a motion that is under the influence of gravity, or that is gravitational influence. And from, if you can remember very well, we were taught that in our elementary school that Gravity is that force that brings everything down to the earth. So a body is said to be under gravity when it is moving at a uniform acceleration, and that acceleration is acceleration due to gravity, which is 10 meters per second square in space. So, and it is under the influence of what? Gravity. Now you should note that when you are throwing something downward, like you are dropping something, because the thing is falling towards the earth, it is in support of gravity. So the acceleration is going to be what? Going to be A is equals to G. But when it is going up, because an object that is going up is actually going against gravity, so it's going to be A is equals to minus what? G. Now note that the velocity at the maximum height is going to be what? 0, because at the maximum height the body is no longer moving up, so it's going to be what? 0. Now also you should note that what? Initial velocity of an object drop from an height above the ground, because when you want to drop the body, it's just like I have this pen, I want to drop it. At this point it is not moving, so leaving it, by the time I want to leave it, it is at rest. So leaving it, the initial velocity was actually 0 before it started falling down. So that is why initial velocity was 0. Now we should also note that for a bouncing body, the height above the ground is what? 0. Okay, with bouncing body. Now also note that the time of fall for two objects. Now what this is trying to say is that if I get two objects, now we have this as a pen and we have this as a plastic. Now by the time you drop the two of them down, the mass of this is heavier than this. But based on what the experiment performed by Galileo, it says that irrespective of their masses, if you drop this, provided there is no air resistance, that is to say this experiment was performed in a vacuum, if you drop these two objects the same time, both of them will hit the ground the same time. The reason is because mass does not have any influence on what? Motion. So mass is not dependent of what? Motion. So that is what Galileo says. Now for motion under gravity, we have two cases. Let's talk about the first case. So the first case is actually when a body is being thrown vertically upward. So when a body is being thrown vertically upward, now making use of the third equation of motion, v squared is equals to u squared plus 2as, we notice that when a body is thrown vertically upward at the maximum height, the final velocity is 0, and the s, which is distance, because it's a vertical motion, the s becomes maximum height, while a acceleration become minus g because it's going upward, which is against gravity. Now imputing this into our third equation of motion, so it's going to become 0 is equals to u squared plus 2 brackets minus gh. Now that is going to be 0 is equals to u squared minus 2gh, and that is going to give us 2gh equals to u squared, making h the solid of formula to get the maximum height. We have that what? H is equals to u squared over 2g. So this is the formula we can use to find the maximum height for a body that is thrown vertically upward. So how do we get the time? So using the first equation of motion, v is equals to u plus 80. So imputing the value, remember that v at the maximum height is 0 and a is equals to what? Minus g. So imputing those values into the first equation, we have 0 equals to u plus bracket minus g times t. So that is going to give us 0 is equals to u minus gt. So it means that our what? U is equals to gt, and t is going to be what? U over g. So it means that the time it will take, this is the time it will take to reach the maximum height. Now if the body is thrown upward and is allowed to return to the position of projection, now the time taken to go up will also be equal to the time taken to return to the height of the line of projection. So it means that the total time of flight is going to be what? 2u over what? G. So when two vectors are in the same direction, this and that. Okay, so let's go to the case 2. Case 2, when motion of body falling freely under gravity. So that is the case where you are dropping a body from an height. So you should note that when you are dropping a body from an height, the acceleration is equal to gravity because the body is falling and is in support of what? Gravity. Now if you use this third law of what? The third equation of motion, Imputing those values, v square, because the body is coming down, the initial velocity will be what? 0. So it's going to be what? V square equals to u square. So u is going to be 0 square plus 2gh. So it means that for us to get the velocity underneath, it's going to be what? V is equals to the velocity at which it will touch the ground. It's going to be v equals to square root of 2gh, where h is the height at which you are dropping the what? Body from. So this is the velocity of the body just as it's about to reach the ground. So again, using the second equation, s is equals to ut plus half at squared. So remember that h, so u is going to be 0, so s is h, so that is the maximum height. So h is equals to 0 times t plus half gt squared. So we have this to be h is equals to half gt squared, and t is going to be square root of 2h over g. So this is the time it will take to reach the ground. So let's get some examples under motion under gravity. So this is example 4. A ball is released from a height of 20 meters. Calculate the time it takes to fall. The velocity with which it hit the ground. So the ball is released. That is to say the ball was dropped. So this is actually case 2 kind of problem. So remember solution. Remember, for a body being released from an height, the acceleration is what? Plus g, and the initial velocity is going to be what? 0, because the ball was actually at rest before it was dropped. So, and the s is what? 20 meters. That is the what? Maximum height it is going to fall from. So the answer is to find the time, and the answer, so now from the what we did before, time is going to be what? Square root of what? 2h over g. So imputing these values, so it's going to be square root of 2 times what? 20 meters all over 10. So the 0 will cancel 0. So it means that what? It's going to be 2 times 2. Why? So square root of 2 times 2 is going to give us what? 4. So the time it will take to reach the ground is going to be what? 2 seconds. So the answer is to find the velocity at which it's going to reach the ground. So velocity is what? gt. So velocity is going to be what? 10 times 2, which is going to give us 20 meters per second. So thank you very much. So you can try to solve these questions on your own and then send the answers to me. So see you in the next video. So thank you very much.